So we've slowly been building up skills that we can use when we're dealing with quadratic equations. Well, what is a quadratic equation? This type of equation in one variable is any equation that can be written in the form ax squared plus bx plus c is equal to 0, where the a value does not equal 0. We can't have a 0 in front here. X is my variable, and the letters A, B, and C are constants. So those are some numbers, positives, negatives, could even be fractions or decimals. But if I have this form, where I have an x squared plus a b times x plus a c equals 0, I can solve this equation in many different ways. And we have many different ways of solving it because this quadratic equation can take a few different versions of itself. It can look in a few different ways. I could have something as simple as x squared is equal to 5, right? That's technically a quadratic equation because it has an x squared term. It just so happens that the other numbers are zeros, but that's okay. Just the a cannot be 0. Or I could have something of the form x squared minus 9 is equal to 0. Right? I could have something like this. Or I could have something more complicated like x squared plus 5x plus 3 is equal to 0. So we have a lot of ways of solving quadratic equations because these can take many different shapes, many different versions of itself. One of the ways we could possibly introduce and try out for any quadratic is factoring. Right? We can all fall back to factoring in a lot of our problems. But sometimes factoring isn't enough. Maybe the equation isn't factorable. Maybe it's that prime situation. But we still need a way of solving for these x values. We still need a way to find the x that's going to make that equation equal to 0. Another way we can solve this is to take these ax squared plus bx plus c forms and complete the square on it. We can change it into that other vertex form. Remember that was the f of x is equal to a times x minus h squared plus k. And once we have this form, if it is equal to 0, right, to make it an equation, then I can use what's called the square root property. Right, subtract the k value, divide the a, and eventually take a square root to undo the squaring of it. But I can use that square root property to solve for the x, to eventually get some sort of x answer. And that can take some time, right? Completing the square, solving for the square root property piece, that can take some work. Well, what if we were to take this form, this exact one, the ax squared plus bx plus c, and apply the square root property to it? Take what we learned in our last section and apply it to this more general equation here. And then once we have it in the right form, use a square root property to solve for x. Well, that process leads to a very important formula. It's so important, it has its own name. And that's what we call the quadratic formula. So that's where it's coming from. It's not just this formula that you had to memorize in any past class, maybe, but the quadratic formula, where is it built? It's built from this equation and the process of completing the square and the square root property. So a little background on how it's developed, how it's derived. So here's the outcome. We're going to say an quadratic equation written in the form ax squared plus bx plus c equals 0. So notice it has to equal 0. We like our variables ax squared plus bx plus c. We like them lined up in this way. Well, it's going to have solutions, right? The x equals part is going to be found by doing the following. Our x value is going to equal to negative of the b value, negative b, plus or minus the square root of b squared minus 4 times a times c. Notice all of that is inside of the square root. And I'm going to divide all of this by 2 times a. So you have your a, your b, and your c from your equation with this outcome of this whole process. The quadratic formula, we're just simply plugging in numbers into these operations. Once we have the values plugged in, of course, to evaluate, we're going to get some answers. We have to remember our order of operations. Now, something to stress and just make sure we remember. To use this formula, it has to be in this form. You have to have your ax squared plus bx plus c equal to a 0. If your equation has x squares and x, but it doesn't equal 0, you want to move things around so that it does equal 0. So you know your a, your b, and your c values. Let's try it out.